What the Montgolfier brothers observed by watching laundry drying over a fire was that air formed pockets that billowed upwards. They believed that the smoke contained a special gas, which they called the Montgolfier gas. And this Montgolfier gas had a special property in which they called levity, to levitate. Their experiments led us to the understanding that warm air rises. So, why does warm air rise? To understand this idea, we see that the flame heats up the air molecules inside the cube on the right. The molecules move faster and faster as they're heated, and they spread out, making the hotter air less dense than the colder air. That is, there are fewer molecules per unit of volume in the hot air than there is in the cold air. So, why does a hot air balloon float in the air? Hot air balloons are based on this very scientific principle that warm air rises in colder air. Essentially, hot air is lighter than cold air because it has less mass per unit of volume. A cubic foot of air weighs roughly 28 grams, about an ounce. If you heat that air by 100 degrees Fahrenheit, it weighs about 7 grams less. Therefore, each cubic foot of air contained in a hot air balloon can lift about 7 grams. Now that's not much, and this is why a hot air balloon needs to be so huge. In order to lift 1,000 pounds, you need about 65,000 cubic feet of hot air. So how does density relate to hot air balloons? Density is the relationship between mass and volume of an object, where the mass of an object is measured in the amount of stuff or matter that it's made of. We measure this typically in grams, found using an electronic balance. While volume is a measure of the amount of space an object takes up in 3 dimensions. You can determine the volume of a regularly shaped object by using the formula length times width times height. Typical labels for this are small things would be centimeters cubed, or things that are larger, meters cubed. Using this property of matter, we can determine if an object will float or sink in a particular medium. When we compare densities, we have to look at 2 objects. We look at an object's mass, and we look at an object's volume. Consider the effect on the relationship between mass and volume in the example above. Let's consider that the mass of these 2 objects are equal. We can see that the volume of these 2 objects are very different. The large object takes up 1,000 times more space. In order to make a hot air balloon float, it's important to maintain a very low mass while maximizing our volume. So does size matter? In terms of volume, when we compare densities of an object,